Live for the office hours of pwn.college, specifically for the shellcoding module. We have ASU students on Zoom, everyone else on Twitch. Let me get on Twitch so that I can see questions and everything. Okay. Perfect. So, what questions do we have? So just to get everyone on the same page, we're partway through the shell coding module. There are 14 awesome levels of shellcode challenges. Hopefully everyone is excited to shellcode and is having fun. Are you guys having fun on Zoom? Gonna take the deafening silence as a yes. Someone says depends on your idea of fun. Someone said 50 out of 50. Awesome. You might see I'm on baby duty right now because it's Labor Day, so this might be a little bit of a chaotic office hours. Someone on Zoom says this is sadistic, but it's very fun. All right, 14 seems to be hurting people. Okay, can we go over multi-stage shellcoding? We will do that. Awesome. All right, let's start with that since that's a concrete question. As long as the baby kind of lets us do it, let's jump over to my terminal. Oops, get rid of these slides. That's from the lecture I was recording. We'll actually, where's the other? Okay, awesome. Now we have, okay. So we're gonna go to pwn.college here. Some of these challenges for the shellcoding might require you to do multi-stage shellcode, unless you are better at shellcoding than we are. Multi-stage shellcoding is a technique. Hold on. Yeah. All right, back. Someone says the baby doesn't like shellcoding. The baby loves shellcoding. All right. She's just upset that I'm a noob at shellcoding. Multi-stage shellcode. Let's say that we have a shellcode here. Oh, that's actually yeah. Okay. So we have a shellcode here. We have our standard preamble that let me just copy it from here. All right, so we have shellcode, some shellcode. This basically does exec bin sh, an example from the slides, and we are somehow constrained to the point where we cannot do this shellcode, just execute the shellcode out the bat. Right, because for whatever reason, either we have too few bytes to actually make this work, something is filtered, etc., etc. Right? How do we get around this? Right? One way is we could do a multi-stage shellcode where one stage loads the next stage and the next stage executes. Right? So let's getting a shell is pretty much impossible since home CTF is set to no SUID. I do not think that is the case. I mean, home CTF is set to no SUID. That was a question on Zoom I just read out. Getting a shell is definitely possible. It's not possible to get a shell from executing a set UID binary in home CTF. So let's get rolling. All right. So what we need to do is read in. So if you launch shellcode, that will read in more shellcode and execute that next shellcode, right? All right. Let me actually start a list of questions to go back to. Someone just asked, why does strace drop permissions? I'll cover that. Okay. So. Multi-stage shellcode. So in order to read in more shellcode, we have to call the read system call, right? This makes sense. We can call the read system call pretty easily. The read system call is system call 0. And the first argument is the file descriptor that we want to read from. Standard input is file descriptor 0. Second argument is where we want to read into. And this is pretty simple. Instead of having this kind of bin sh string here, we're going to have a where to read label, and this will just be some label. I don't know, whatever. Let's put a bunch of no ops there. So the second argument will be a pointer to our where to read, and then we will the third argument to read, and of course I'm going off memory, but you can look at the man page. File descriptor, the buffer to read into, and the number of bytes to read. And this number of bytes, we can do whatever, right? Let's say we read a kilobyte of shellcode. So this is stage 1 of our shellcode. Let's save it as stage 1.s. And what is stage 2? Stage 2 is going to be our old bin sh shellcode. Of course, as someone mentioned, bin sh drops privileges and so forth, but let's for the purposes of the demo, let's have this bin sh shellcode. So this will be our stage 2 shellcode. All right. Let's compile assemble our shellcode. Stage 1, stage 1.s, dash no stdlib, dash static, and our stage 2. Okay, and then we do our obj copy. And same for stage 1 and stage 2. Okay, so here's my stage 1 shellcode. And here's my stage 2 shellcode. All right, you can see stage 1 is shorter than stage 2 because there's no bin sh, etc., etc. The key thing is, of course, to make your stage 1 shellcode pass whatever restrictions that you need to pass. This shellcode still looks pretty loose, and it probably won't pass, things with many restrictions. But that's a separate topic. So now we have stage 1 and stage 2. Actually, when we can test all of this out by compiling this with an executable stack. No, it's a little trickier than that. I forgot the arguments. Hold on. Let me go to how do we compile it with an executable text segment so we can emulate the shellcode. I forgot the exact arguments. Let me look up my own slides. It was dash L dash N. Yeah, I think it was dash L comma N. Dash W L comma N. Yeah, thank you, Ricky. Someone on Twitch is asking, does obj copy need to be writable? Obj copy, I'm not parsing the question. The text segment doesn't have to be, section doesn't have to be writable for obj copy to work. But anyways, this makes, tells the linker to make the text segment executable. Oops. All right, and now, dash n. And now we have our stage 1. I can execute my stage 1, and if I strace it, I see that it reads in something for my stage 2. And of course, I can execute stage 1, sending my stage 2 shellcode in, and something is wrong. So it reads into a buffer at OX90. That's not good. Oops, I did move instead of load effective address. So usually these live sessions are in class and my students catch me making mistakes. Everyone on Zoom, feel free to holler if you see me making a mistake. So right there, what I did, instead of loading the address of this position that I want to read something into, I moved the value at that position into the pointer, right? So instead of RSI having the address of this location, it had the value at the location. That's bad news. So let's do the load effective address. All right. Now we have to, of course, rebuild the shellcode and obj copy the shellcode out. No, sorry, we don't have to do that because that's just stage 1. All right, we strace it. We rebuilt it, right? Load effective address, RSI, rip where to read. Yeah, obj copy, I shouldn't have to obj copy stage 2. Someone on Zoom says obj copy stage 2. Stage 2 isn't doing this read. Stage 1 is doing this read. Okay, let's just go back. First principle, stage 1.s. REX 0, success. Can you still hear me on Zoom? Oh, it didn't save. You're right. It didn't save. Why? Yeah, okay. People can still hear me on Zoom, it seems. Okay. It didn't save. That's weird. That's really weird. I don't know why it didn't save, but now we're good. All right. So we compiled it now. We can strace it, and you can see that we read 38 bytes. That is the size of my stage 2 shellcode. du is a utility that measures the size of files. So 38 bytes is the stage of my shellcode. It read 38 bytes. That's these bytes. And the next thing it did was exec bin.sh. Let's run through it in GDB. All right, so we're running stage 1 in GDB. We're going to break at start. And we're going to run with stage 2 as our input. Raw. All right, so we're broken in start. Or we braked in start. So here's move REX 0. That's the move, right? So we can step. Move our DI 0. That's the standard input. So this was the syscall number. Standard input, and I'm single stepping through my shellcode and seeing the effects. I can see info reg. These are all of the states of the state of all the registers right now. So most things are actually start out at the beginning of program execution as 0. And the important one that we're about to set is RSI. That's the pointer to my buffer. So let's see where are we right now. So that's what we're about to set. By the way, if you are tired of doing this x/i RIP every time you step in GDB, you can do disp I RIP. This will have it always, every time it stops, will display whatever this is in that expression, which in this case is RIP. All right, so this is about to load the effective address into RSI of the instruction pointer plus OX9. The instruction pointer here is this well, it's 40E2 in our ELF file, but of course it is only 14 bytes into our shellcode. Let's see what is there right now. So we can examine, let's say 10 bytes, let's do 10 instructions in RIP plus OX9. And here they are. RIP plus OX9 is... that's right. So this is RIP plus OX9. This RIP, it's a little tricky, is actually after this instruction. And this instruction is some amount of bytes along this. When this says RIP, when an instruction executes, is always pointing to the next instruction to execute. Layout regs. Oh, interesting. Anyways, RIP here means this address right here. So start plus 21 bytes into our shellcode, plus 9. So 21 plus 9 is well, E9 plus 9 should be pointing to right here. Let's take a look. XI OX plus OX9. OX9 is equal to 9, of course. Enter. Oops. I dereferenced it. There. All right. So this is me examining the instruction or the memory location that this refers to. Again, this is the instruction pointer, so the address of the next instruction when this instruction is executing, plus 9. And that's what I did in my runner. Uh-oh, she dropped her book. Let me finish this and I'll get her a new book. In our runner shellcode. Why did my iPad stop working? Sorry if I missed some Twitch questions. My iPad stopped working. In the runner elf, our shellcode is loaded at whatever base address we started out at, or the entry point is at this 40D4. By the time we get to this load, the next instruction is 40E9, and this address is referring to this where to read label, which is 40F2. Awesome. All right. Point is, there's nothing here right now. If I if I step over the instruction, now we're going on to how much to read. So now we're about to execute the syscall. Let me do info-reg. Here's what things are looking at. RDI is 0. That means standard input. RSI is pointing here. This is where we will write our read in our shellcode. Right now, it's basically just that no-op that we put in, and then whatever used to be there before. And then what else? RDX is how much we're going to read. That is 1024 in binary and a decimal, OX400 in hexadecimal, and RAX is 0, meaning the read syscall. So let's step. Now we have executed that read, and right away we see that this F2 where we step next should have been a no-op. It was just a no-op, but we just replaced it with some code, and we can disassemble again this location, and now we see shellcode here, right? So we move the syscall number of exec VE. We load this RIP plus 10, so it's this 4 plus hex 10, so plus 16. So 40100, which means it'll go to here, and this is where, of course, bin sh lives. I can actually show you that. We can look at it now. Now there's bin sh in here. We just read all of this in. And then here are the other instructions we just read in that finish setting up the exec vsyscall and trigger it. So now we can step, 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 step. We're about to hit the syscall. Boom. We have just launched bin dash, because that's where bin sh links to, and success. All right, there are two, let's restart this program. Two suggestions on Zoom. One is layout reg. It's a whole like different layout for GDB, so you can go through and it's all nice and graphical. It shows you what changed. The other one's layout ASM, just for the assembly. My recommendation, if you're going to start tweaking GDB, is to install something like pita, pwn debug, or pwn GDB. They're in my shellcoding slides. It's basically a GDB plugin, for lack of a better explanation, that will allow you to do all sorts of, or that'll make it look really fancy and really nice. Okay. So that was multi-stage shellcode. Of course, you have to also inject your first stage normally, but I'll leave that as an exercise to the reader. And multi-stage shellcode requires either your first stage to make some code writable, which, just so people don't go off on the wrong tangent, I don't think any of our current challenges require that, or it requires there already to be writable, executable pages that you can read into and jump to. All right. Question on Zoom. What techniques in general do you use to make shellcode smaller? Good question. I'll give you two right now. Well, yeah, I'll give you a couple of tricks. One trick. Let's look at our stage one. One trick is XOR instead of moving zero, right? So here, this is a move zero. Let's just remove. Actually, I have a utility that makes exploring this stuff much easier. It's called Shell Tools. Do I have it publicly available somewhere? You can do the same with pwn tools. I'm just going to do it with shell tools because it gives me a little more analysis. So let's say we're talking about move RAX0, right? So here is my, this is a script I wrote that assembles all of this, and then obj dumps it, hex dumps it, gives it to me in an ability, a form that I can paste into a C script, a Python 2 script, a Python 3 script, a shell script. Let me see if I actually have it available. Did I public? Oh, yeah, it's public on GitHub. Okay. Yeah, so it's in renewing the shellcode challenges for you guys, I kind of pulled together these loose scripts into a Git repo and push them. If you're interested, it's on here, github.com/shelltools. There's an assemble program there that is that'll assemble your shellcode, and then also like strace it to see what the shellcode does and so forth. Obviously, this guy just moves RAX0 and crashes, but we can see if you move RAX60 and syscall, see the strace actually shows it down through the exit 0. Okay, so making things smaller. So here I did move RAX OX 3C, right? And this takes an enormous amount of bytes. This takes this whole shellcode is 9 bytes in size. This thing takes 7 of them, right? And it has a null byte in it, so it's kind of really bad. But at the end, RAX is 60, right? So our goal is to do move RAX 60 in the same in fewer bytes than 7 with the same effect that RAX ends up with 60. Actually, let me get the baby a book. I'll be right back. Yes. What? All right, back. Okay, so how can we do this? One, we can if this was move RAX 0, which also takes 7 bytes, it'd be nice and simple, right? We can do XOR RAX, boom. We're down to 3 bytes, and we have the same effect. But has anyone done level 3 where you can't have this H, right? So XOR RAX, if you look at the hex dump, here it has an H here in the printable representation of these bytes. So this OX48. What is this H? This H is actually the way that AMD built AMD 64. Basically, used to have instructions such as XOR EAX. Let me actually, for reference, bring up the shell coding. Is it in the shell coding or in the fundamentals lecture? Let's see. I'm actually working on a new fundamentals series. I'm going to pull up slides from that. I'm hoping to record it when I have time over the next few weeks. That will hopefully fill in even more gaps. It's just a lot of work to call it the secret life of Hello World. Just a lot of work to build it. I'm at 100 slides. But let's get to the assembly part of it. These guys. All right. So partial access on AMD 64. You can access parts of a register. And so when I did, let me show you this slide a little better. Okay, when I did EAX, what I'm really accessing is the lowest 32 bits of RAX. So half of RAX, right? And XOR EAX, if I assemble that, assembles to 31C0, right? Whereas XOR RAX assembles to 4831C0. So you can deduce that 31C0 means XOR EAX, and this 48 turns it into XOR RAX. And you would be correct in that. Let me figure out where I have this slide talking about that. Oh, right after that. Okay. What? Okay, slide 67. It's a lot of slides. All right. So what happened when AMD built AMD 64 is they realized that backwards compatibility is very important, right? And this has been the case throughout the life cycle of x86. From a 386's ability to run 16-bit code all the way through your modern 64-bit processor being able to run 32-bit or 16-bit code still, right? And the way that they do this is that most of your instructions on your processor will still, with some exceptions that are very important for the homework, will operate on 32-bit code, on 32-bit data, such as the lowest 32 bits of registers. I'm sorry, I have to get her a new toy because she dropped this one on the floor. One second. Ты что делаешь? Ты что делаешь? Alright, we're just gonna bring the whole toy box.
Не надо это на пол, окей?
The baby's asking for new shellcode, someone says. Okay. Where were we? So most instructions on 64 on AMD 64 still operate on 32 bits unless you provide a special prefix to the instruction that tells it, hey, this is 64-bit land. We are gonna do 64-bit stuff. And the way this looks like is the prefix rex, R-E-X, and you typically don't write that in your assembly, but your assembler will write it when it figures out what sized operands you're working on. Since we are doing 64-bit operands here, it says, okay, rex, move RAX, RAX. And that's this instruction. And rex assembles into an OX48, which happens to be a H. Okay? So when level 3 says no H, what we're really saying is you cannot have the prefix that turns things into 64-bit mode. Now, not all instructions require that prefix to work on 64-bit data, but that's the challenge with her. So the point is, how did she drop this so fast? We're gonna run out of toys.
Не надо кидаться, не надо кидаться. Ну, кем ты кидаешься? Вот вы сейчас вот так, вот так. Не надо.
Okay, sorry about that. So, looking on Twitch to make sure I didn't flash butt crack. Okay, we're good. The Rex byte, yes. Okay. Hacker's crack. What was I saying? Oh, yeah. So we see a difference between XOR RAX, RAX, and XOR EAX, EAX. And it's that H byte. The interesting thing is the effects of these two instructions are exactly the same. If we let's drop into Rappel. As a reminder, Rappel is a really cool tool where we can type instructions and it'll execute them. If we say, okay, let's fill RAX. Oops. Sorry, brain dump. Let's fill RAX with all Fs, right? If we do move AL OX42, we'll just replace 1 byte of RAX. If we move AH OX43, we will just replace 1 byte of RAX. So AL is this byte, AH is this byte. If we move into AX, 1, 1, 2, 2, 3, 3, 4, 4, we will just replace. Oops, you're right. We will just replace these 2 bytes. AX is the lower 16 bits of RAX. But if you move into EAX, 1, 1, 2, 2, 3, 3, 4, 4, because of a quirk of history, a historical quirk, a decision that AMD 64 made that simplified things somewhere, this acts differently. This zeroes out the half of RAX that it won't touch, right? So any data that touches EAX, EBX, ECX, EDI, and so on, the registers, the 32-bit registers, will actually zero out the top half of the 64-bit registers. And it zero out, actually, if I remember correctly, it'll sign extend. Nope, it zeroes it out. Yeah. So it zeroes out the top bits. What does this mean for us? This means that if we move RAX -1, so we have all ones in RAX. If we XOR RAX, obviously this will go all 0. Okay? But also, we reset that and XOR EAX, it'll also go all 0. So, by doing XOR, instead of XOR RAX, by doing XOR EAX, we can save a byte to zero out RAX and still zero out RAX. Pretty cool. Okay, so our original goal, if you remember, was moving 16 to RAX, not zeroing it out. And zeroing out RAX doesn't necessarily solve that, but it gets us closer, because once we move 16 to RAX, or once we zero out RAX by doing XOR EAX, which is just 2 bytes, now we can do something very cool, which is to move into AL instead of RAX. Why is my terminal not my slides not showing? What the hell? Oh, hold on. That's weird. 1 second. There we go. Okay. Okay. Slides on the side there, so you can see. Instead of doing move EAX, move RAX whatever number, we can move AL whatever number to just fill in the least significant bits, and that's all that we need, because the value 60 fits into 8 bits, into just that lowest bit of AL. And there we go. XOR EAX, move AL OX3C. You can try it in Rappel. XOR EAX zeroes out EAX, of course, and move AL 60. Now RAX is 3C. And best of all, instead of 7 bytes, all of this takes 4 bytes. Pretty cool. All right. So, what does this mean? This means that we can do exit in 6 bytes instead of 9. Pretty awesome. All right. Questions on that? Let me add, going over level 1 to the list. So assuming you do multi-stage shellcode for 14, I'm reading a question on Zoom, the minimum amount of bytes you would need would still exceed 16, or 6. I did not say that. I would not agree with that question. I guess the biggest hint I can give for 14 is your shellcode doesn't run in a vacuum. Your shellcode hijacks execution of a program that was running, that had hopes and dreams, that had goals and accomplishments, that had done something in the past, right? What did it do in the past, and how can you use that to achieve your goals? That's the key thing to realize when you're shellcoding in extremely constrained conditions. What can you pick and choose from existing program properties and so forth, program states, to achieve your goal. Okay, so this is one way of shrinking your shellcode. Another way, there are some other interesting tricks you can use based on interesting effects of certain instructions. For example, the mol instruction, right? Hold on, let me check what's going on with Bebe. I will be right back. I have to change a diaper. Why don't everyone watch some Matrix to get in the hacker mood? I'll be right back. All right, I'm back. Hopefully that the Matrix got you all in a good hacker mood. All right, let's talk about instruction side effects. So there are instructions that are useful for shellcoding in certain contexts. I'm gonna call out one. So oftentimes in shellcode, you have to set RAX, RDI, RSI, and RDX, right? These four, and then trigger a syscall. So an instruction that can set both, set two different registers or multiple registers is great. x86 in 32-bit had an awesome set of instructions, push A and pop A. And pop A would read in would pop all of the registers off the stack. Right? That saved a lot of space, and it was super awesome. But that no longer exists in 64-bit. It's gone. Or at least in 64-bit mode. So but there are still instructions that can help, right? One of these, for example, let's say we had values in RAX and RDX, so in the syscall number and the third argument to a syscall, and we wanted to wipe them out, right? We can do that all at once, and if we had 0 in another register, right? So we do XOR ESI. So this is 2 bytes. It'll zero out RSI, but that was already 0 in this example, but that's fine. And then we use mul ESI. Mul is a very cool instruction. It will multiply whatever is in RAX by whatever, so that was -1, by whatever you provided to the instruction. It'll multiply whatever was in RAX to whatever you provided to the instruction, so by ESI, right? And then it will also, because multiplication can overflow very easily, it'll put the overflow into RDX. In this case, we're multiplying by 0, so we are wiping out everything in RAX and everything in RDX with one instruction, with mul ESI. Mul ESI is how many bytes? 2 bytes. So in 2 bytes, we zero out RAX and RDX, as long as we have another register that is already 0. That's a very useful thing. You can sometimes be even more clever by actually using it to set specific values into these various registers. But just the knowledge of like the multiply instruction can help with shellcoding sometimes in certain situations. On Twitch, we have someone says the baby's cute. Yes, she's very cute. She's very cute. Yeah, she's very cute. Usually we have the baby schedule set up in a way that she's not teaching, but didn't work out for Labor Day, huh? Yeah. Okay. So Kyle Steve, question on Zoom: when you have just one H byte left to get rid of. I'm gonna give you one more hint for the H bytes. Most things, so you do XOR RAX. This has an H byte. So we talked that XOR EAX doesn't, of course, is the 32-bit version. There's one thing. Push. Oops, of course, that's push RAX. No H byte. Pop RAX. No H byte. So when AMD 64 was creating when AMD was creating AMD 64, in their infinite wisdom, for whatever reason, I'm not sure, they made push and pop work on 64-bit data by default without the Rex. Oh yeah, and also someone mentioned on Zoom, notice they're also 1 byte. That's incredible. They're a single byte instruction that does something actually pretty intense. They will, a pop will take the value that's at the top of the stack, move it into RAX, and then move the stack. That's pretty good. All right. So, other questions. Let's see. S-trace permission. So we're going to move on to my list of questions that I've been taking notes on. So someone joined in a little late, I think, and is asking about multi-stage shellcode. We went through that at the beginning of the office hours, so that'll be in the recording, or you can probably go even rewind to it now on Twitch, but it'll be in the recording afterwards. Moving on to S-trace permission. So you might have noticed that when you S-trace something, the setUID bit does not take effect, right? Well, that is absolutely correct. There are actually several different scenarios in which the setUID bit doesn't take effect. If you look at a program funny and it's marked setUID, the setUID bit will not take effect because, it's a huge security risk. The reason that S-tracing a program doesn't honor setUID is because when you strace it, you launch it with a debugger attached to it. strace works by attaching using the Linux debugging functionality, which is called ptrace for process tracing. With attached to a process with ptrace, this is exactly what GDB uses as well for debugging. That's how GDB debugs. You can do anything to that process. You can read memory, read registers, write registers. Obviously, there's a huge security risk. So when you start a process with ptrace, the kernel will not honor the setUID bit. So that process will start not setUID. Now, you might have a question, well, how do I debug my freaking shellcode then? Right? This is exactly why we gave you practice mode in pwn.college. Like, this is literally exactly why. If we go to, pwn.college, let me just launch up baby shell just to show this. Oops. Now let's do something where I don't have to type a lot because I have this baby. Let's do baby suid. So I'm going to launch baby suid in practice mode, right? What do you mean invalid path? I'm going to have to follow up with Connor. Connor, are you on this call? Oh, wait. Oops. That's not the path. Sorry, I'm a little bit more distracted than my usual self. Here's the path. Practice challenge. Okay, so that is launched up. Let's see if the baby will be satisfied sitting down again. Okay. 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 Connor's in Twitch chat. Great. Anyways, all right. That was my error. So I spun up baby cat. Okay. Wait. Why can't you see what I was just doing? OBS is having issues. That's what I was just doing. I was spinning up baby cat. All right. So let me SSH. Oops. Okay. All right. So we are. Everyone remembers baby suid. Oops. Probably very lovingly. Bin cat is setUID. If I launch bin cat /flag, I get the flag. If I strace bin cat /flag, there's no strace on here. I won't get the flag. It won't work. Why is this? Like I said, when you launch a process with a debugger, it will not be setUID because otherwise you would have complete control, right? In the exact same way you do strace, you could do GDB /bin/cat then and mess around with all the values of memory and get the flag super easily. So this is why we gave you practice mode. So you can sudo and become root, and now you're already root. You can just, read /flag directly. But now you can also do strace bin cat /flag, and if strace was installed, it would work. This is exactly why we have practice mode. You can do all of your debugging as root on your shellcode, stracing, GDBing with the actual flag. Everything should work. Then you can log out, rerun the challenge in real mode instead of practice mode. And then when you log back in, Now you don't have sudo, but bin cat or whatever, the flag is now the real flag. Again, this is my flag. Don't submit my flag. But this is for bin cat. Oh, for baby suit. Okay, so that's why set UID drops or does not honor strace causes set UID to not honor those permissions. Causes the kernel not to honor the set UID bit. That's what I was trying to say. Okay. Someone had asked, is it possible to do multi-stage shellcode if there is no write permissions on memory? Yes, but it gets very complicated, and we didn't intend for you to do so in this assignment. It's a good idea, and probably we should actually make a level 15 that requires it, but typically what you would have to do is execute the mprotect syscall to add write permissions to a page of memory and then write into that memory. But we're not going to do that this year. But you might have just doomed, whoever has that might have doomed next year's class. Okay. Level 1. We're hitting the end of the hour. That was fast. Have you really been streaming for an hour? Crazy. Am I still hearing people on Zoom? Someone say something. Okay, beautiful. Thank you. I can still hear you. All right. I feel like I'm getting a little better at catching the chat questions from both Twitch and Zoom. All right. Anyways, on Zoom, someone asked to demonstrate level 1. Let's do that real quick. So actually, I'm going to solve level 1 if I can live right now. You can have it as a free flag just for showing up to office hours. Baby shell level 1. I already solved it. Well, anyways. Let's just run. I'll get you the flag. Someone said, at what point could we share our solutions for pwn.college? After the semester is over, please. This is a class at ASU. Okay. So we're and then someone let me add a note. Uh-oh. Hold on.
Что? Что, опять подгузник? Опять подгузник?
Alright, quick break. We're gonna do another diaper change. I'll be right back. One sec. Have some. Oops, hold on. Have some matrix to get everyone in the right mindset. I'll be back. Okay, come on. That way. Okay. All right, we're back. Cool. Let's do this. All right, so we are SSH into Baby Shell level 1 testing. And actually, let me actually relaunch it in practice mode so that I can also show you how to debug your shellcode. All right, we're in testing mode. In my home directory, let's just move all this away. And we're gonna start up our shellcode.c or .s. What we need, of course, is just this global start. We need a start label, and we need our .intel syntax to do no prefix. Okay. Awesome. Now we can start our shellcode. So first, let's start with an exit shellcode. Of course, this won't solve the level, but we can start with it. Okay. So we're gonna move the exit syscall number into Rx. I'll do a syscall, and that's it. That's our entire shellcode. Right. So this will exit cleanly with some exit value. Of course, let's compile this. No cdlib static shellcode elf .elf to stay with the thing. Okay, awesome. And then we'll obj copy it out. So let's strace it. Let's strace it. So you saw we did a clean exit. That is very awesome. And let's. Oh my God. All right, so now we do obj copy, dump section. We'll dump the section into our shellcode raw from our shellcode elf. Okay, here is our shellcode raw. Nice and simple. There's that H, and then it's just exit 0. So now we can run baby shell, and it says, okay, reading memory into stdin, and we can pass it in to stdin shellcode.raw, and boom, and it executes our shellcode. Okay, we can strace this, and we'll see what it does. It closes all the file descriptors, and then it executes shellcode. And this shellcode does an exit, and now we have a different exit value. Why? Because the value in RDI was some crazy thing, right? And the exit exits with the value in RDI. All right, awesome. Now let's make shellcode that actually does something. We're gonna move the value, the syscall exec.ve into RAX. We're gonna move into RSI a string pointing to bin sh, and that's gonna be here. Gonna make a new label for it, string that bin sh. Okay, and we do again like we did earlier, load effective address of that string. We're gonna move into RDI, so that's sorry, this should be RDI. Move into RSI 0 and RDX. So this is if we go ahead and do man exec.ve, this is the path is the first argument, argv is the second, and nfv is the third. We don't care about argv and nfv. We just want the path. And this is shellcode. If we run this, we will call bin sh. That is awesome. Let me prove this to you. Okay. We can strace baby shell, give it this shellcode.raw, and what we see, it close, and then it maps the shellcode, it says, and there's the memory map. Then it reads it, then it executes it, and then our shellcode executes bin sh. Then bin sh runs, and of course there is no more content, and then it closes. So what we can do actually, instead of doing this, is here, let's make a file of commands that we want to run. Let's do echo hi, and we can cat shellcode.raw, and then commands. Can we do this? No, because of the way that it reads. So let's just do it a different way. Cat shellcode.raw, and then cat, and pipe all of that into baby shell. And now we execute the shellcode, and here's our shell. Awesome. Problem is, it dropped privileges, right? We used to be running with effective ID of 0, and now we are running without effective ID of 0, which means we're screwed. sh will drop privileges unless you run it with sh-p. This is much harder, but I will show you an alternative. Actually, why don't we just do that? Well, no. Let's not be crazy. Okay. How should we approach this? Well, there are multiple ways. One way is we use something that doesn't drop privileges. There is a shell called KSH, but it's not installed. KSH won't drop privileges. You can write your own custom program. Oh, ZSH? ZSH is also not installed. I don't know if ZSH will drop privileges. You should test. There's a lot of different things you can do. One of them is to write your own program that you will execute instead of bin sh. Right? Bin sh is just a program. It's not magic. And we're going to write a program called cat flag. I already wrote it, in fact. It's right here. All this program does is open the flag and send it out to me. Right? So I can compile it. Okay. I can run it. Of course, it doesn't produce anything because the flag is not readable by my user, but this is practice mode, so I can use sudo to test it out. Right? So that's my practice flag. Okay. Does Python drop privileges? No, Python does not. So we could actually run Python, right? User bin Python. Let's do that. That's pretty cool. That's a neat idea. So we look at. So we'll do bin. What up? Что случилось? Где? Вот. Держи. Okay. So we do user bin Python. This is an interesting thing. And now we're going to actually use user bin Python instead of bin sh. Let's compile. Let's opt copy our shellcode out. Let's do our cat. Okay. It doesn't seem to fly. But it is executing something. It's waiting for us. Interesting. Yeah. Mm-hmm. Okay, so there's a question on Zoom about send file. Let me run this, and then I will rewrite the shellcode to use send file, and we'll go through that. So we're gonna execute cat flag instead of sh. And that is my cat flag program in my home directory. It does not have set UID, and it's pointless. The home directory is mounted in a way that does not allow set UID programs to be honored. This cat flag, if I run it with root privileges, cats the flag. And we're about to run it. Oh, the baby's getting upset. We're about to run it with the privileges of baby suid, which is effective user ID root. So let's run it. So we do our cat shellcode. Hold on, let me compile it. Opt copy the shellcode out. We can cat shellcode raw. Boom. And there we go. Right? So let's say that hadn't worked. We could strace it. And of course, when we strace it, the open fails of my cat flag because strace does not honor the set UID. But if you want to strace it, you can of course sudo strace, and that will also work. Okay, that is how you solve level 1. Basically, I did this. I can also log out and restart level 1 without practice mode. Hold on. Rerun it, restart it without practice mode. SSH back in. And literally hit up a couple of times. I didn't save my history. Well, of course, my home directory is all saved. I can just copy paste that same command. And there's the real flag for my instance, for my level 1 testing 1. Don't steal that flag. Get your own level 1 testing 1 flag. Cool. Okay. Oh, interesting. Connor on Twitch said you can use IPython instead of Python. Okay. Is there any way to use symbolic links to prevent needing to put a long file name in your program? This was asked on Zoom. Yes, there is. Absolutely. In fact, someone on Zoom says just name the file a single character. If you don't put the full path, if you just put A, it'll look in the current directory for a file named A. That's very useful. Someone says, for 13, do we need to change our .c file? I don't know what you mean by your .c file. I didn't have a .c file anywhere in this. Oh, do you mean like catflag.c? Whoever's asking that on Zoom? Catflag.c. For 13? I don't think so. Connor, is 13 special in a way that would require changes to the .c file? Connor said he doesn't think so. Oh, okay, yeah. 13 is level 13 is just 12 bytes long. Yeah, I mean, why? I don't think it's special in any way that changes what you have to execute. You just have to have shellcode that is less than 12 bytes. There was a question about home CTF with set UID permissions. So the no SUID flag that is on home. So if I do mount, I can see on my home directory. Yes, here. No set UID for home CTF. This means that if I put a set UID in my home directory, a file that is set UID. Let's say I launch up baby suid and I make chmod set UID, and then I chmod with a set UID bit my cat flag binary. That won't help me. If I execute cat flag, it won't automatically get root access. Now, if I execute it by exploiting a set UID binary that lives outside of my home directory, it'll still run with root access. So hopefully that answered the question of how to get around the fact that /home is mounted as no set UID. Someone said on Zoom that if we can't write to /, which we cannot, this is not a writable file system, how can we get around having to include a full path? Well, let me show you this. Let's see if the baby will let us do this.
Да, можно, пожалуйста, пожалуйста.
Okay, we might have to be very fast. Let me edit my shellcode. Here I'm running home CTF cat flag. I can just do cat flag, and it'll look in my current directory. So let me compile it, opt copy it out. If I am in / and I do that, it won't work, right? It crashed. Let me show you why. We're gonna strace it. It tries to exec the cat flag, and there's no such file or directory. What it's gonna do is look in the current directory. If there's no /, it'll resolve it relative to the current directory. Guys, this is gonna be the last thing, and then I have to go take care of this situation. If I go back to my home directory, where there is a cat flag file in the current directory, and I run it, then it works. It doesn't work because I strace it, but if I don't strace it, what you can see is that it's executing cat flag, and that works. And here's my flag. One final thing, it's the same for, if there is no / at the beginning of a path, it's a relative path. I can do .. or cat flag, right? This will be important for this next homework, actually. If I'm in a directory where there's a .. cat flag, and I run this, okay. We might be out of luck. I don't have time to debug this. Oh, it's still exec. I didn't. GCC, opt copy, run. Boom, it works. All right. So everything else, please. That's it for office hours today. That's it for office hours today. Sorry about the crying baby. We are going to have office hours tomorrow. Connor holds his office hours at 2 p.m. Arizona time. If you have other questions, email me. If you email me, please CC Connor. That's the number one problem with emailing me, is that when you don't CC Connor and I'm buried in some insanity, I am not as responsive as I would like to be. But if you CC Connor, then the chance of getting a fast response increases a lot. Also, partially because I don't like dumping that load onto Connor, so then I try to do it faster. But also Connor is extremely responsive. Cool. Otherwise, see you on Wednesday. Please make sure to watch all of the set UID lectures. The two up right now are ones that you will absolutely need for the first couple of levels of the homework, and then after that you are going to, I will put out tonight 2 more that you should also watch by Wednesday. Cool. Thank you very much for tuning in to pwn.college office hours, and I will see you on Wednesday. Ciao.